Alright, I'm Matt Jones and I'm making an immersive RPG in Godot. And this is the third video in how we can do active ragdoll skeletons with breakable limbs that can flop around or be ripped off. Okay, and anyway, before I start, let's do a plug. Uh, all of the videos and everything in our socials are at immersiverpg.com. We have a Patreon if you want to help contribute and so I can work on this more hours, then you can donate. And we also have a YouTube with all of our videos and a Minds and a Rumble and all that. So if you want to help, you don't want to pay, you can share our links and videos and whatnot. And the source code for today's project is MIT license. It's going to be at github.com/immersiverpg/example ragdoll. If you look down here, we'll have branches, and I'll put the newest one under probably master, but for right now it's under Godot 4, and I'll have the old ones up here anyway. So anyway, I recommend watching the two previous videos. Even though those were Godot 3, this is now Godot 4, so everything works with the new Godot hotness, so it runs even better. Let me show it running. Here we have an NPC doing a slight idle animation. If I shoot it in an arm, the arm will twitch a little bit because it's an active ragdoll. That means that it's being driven by physics and also by animation. Then it can kind of interpolate between those two, so it'll do both at the same time. And now that I shot the arm twice, it's broken and flopping around. And if I can throw soda cans, if I throw one and hit it, it will flop naturally. Apparently, this is how it works in Kenshi or whatever that one game is. I still need to try. But you can flop it around. The joints work like they're supposed to. If you hit them in the head will bob a little bit. And if I shoot the arm again, it should break off. Okay, one more time. Break off. There we go. And it's its own separate skeleton that works how it's supposed to and has the correct joint constraints. So if I could get it shot at the correct angle, it would turn the elbow joint or whatever. If I push M, the NPC will walk around, and I could shoot him while he's walking, and it'll make arms and legs break off. If I could hit it. So basically, what I'm doing is there's one skeleton for that's being driven by animations, one skeleton that's being driven by physics, and then it interpolates between the two to draw this mannequin on screen. And then when you break a limb off, like when I break the arm here, it's actually a separate skeleton now because Godot doesn't yet have that ability. So the arm is its own separate one that's anchored to the shoulder, so it can flop around like you would expect, but it's not actually part of the same skeleton. That was one of the things I couldn't figure out on the previous video, but now we can do it in Godot 4, so that's really neat. Um, this soda can that I'm throwing, it works a little bit differently than how you would expect. I have it as a rock here, but it's a soda can. Basically, we have a shape cast. I think that's new in Godot 3.5 or 6. It's like a ray cast, but it has a shape that's this cylinder here, which projects out. Because this soda can is small, and the NPC's arms are small, and when I throw it, that's going pretty fast. So if we just use regular collision detection, it would go through the arm a lot of the time. But now I could, because it's using a shape cast, it'll know even if I'm throwing it 100, like 1,000 meters a second, like the speed of a bullet, it will still hit the arm. So when the can is blue, when I first throw it, I think it's actually throwing 10 at a time. The shape cast is turned on, but then as soon as it hits something, it turns red and to notify me that it's not running the shape cast, because that's really uses a lot of CPU power. So if you're using shapecast, make sure not to keep them running because it has to cast many times as something is moving. So anyway, that's neat. Oh, I also let me restart it. I added pushing. So if I want to shove this NPC with P, I can shove it, and when it hits something, it's gonna ragdoll like you would expect. And if you push if E, you can toggle dead or alive, and it'll switch between being driven by just physics and by animation. So there's still a couple of small issues, but if you look when it ragdolls down, it's moving how it's correct, how it's supposed to. So like the knees don't go forward, they go backwards, and the elbows go forward and whatnot. So that's really cool. Probably should add a getting up animation so we don't have this weird kind of reverse T1000 thing going on. So there's a little bit more I could do to it, but that's really cool. And I have this in the actual game, but this is just part of the example. And let me see how the issue I was having with Godot 3 with the mannequin was the joint constraints. And one thing you'll notice is this is super busy with all the gibberish. These are the cone joints. I think they're actually working on this for Godot 4.2. This is 4.1, where there's less stuff drawn on the screen. So let me see if I can hide these so it's not just covered in gibberish. There we go. So now if you go to, let's see, the right leg, make that visible. Let me get rid of the actual mesh here so we can see just the bones. Like this is a hinge joint, whereas before we were doing just pin joints. So like for example here it's set to have a hinge joint, so it'll work like a joint on a like a door. When you open and close it, it'll have a constraint where it only goes a certain distance and then stops. That's what these are for. Right now I've set it to 90 for the upper and -10 for the lower. And if you see, this shows it the range, and if you can change it. So that works properly now. And also I'm using Jolt physics. So if you go down to where is it? Physics. Here we go, 3D, and then we have Jolt physics selected. This is a lot better than the regular Godot physics. It seems to be about 3 times as fast, but I know that's totally subjective. It's going to depend on how it's working, but it's a lot less jittery. Things won't continue to move around crazily. They'll slowly run out of energy and freeze. Instead of, so if you look at the old videos I did, there's NPCs where they're dead on the ground, but the hands and feet will kind of flop around forever and ever and never run out of energy. But now with Jolt, that fixes that. Things are a lot more realistic. You can have small. Oh, let me see. Show this real fast here. See how I have all of these stacked up, these cans. Um, if you were to do this and some of them are falling because there's little tiny gaps. I need to adjust it. But if you tried this in the other Godot physics or bullet physics, all of these would just fall over and it would use a lot more CPU. And like, see here how I have all of these stacked on top of this cluster here, which is stacked on top of this. So it's like the weight of these is holding this in place, which holds this. There's no way you could get that to work in the previous Godot physics or bullet physics. It works how you'd expect it with Jolt. So that's fantastic and awesome. But with that, there are a few things that don't quite work, like the bias or the softness or the relaxation. It says it's not implemented yet. So I'm expecting that to be working in the future, but for now we don't actually need that, just for the constraints. So this is what stops the legs from like flopping forward where a knee wouldn't move and whatnot. So that's how we got that to work. And what else is there to show you? Um, Basically what we do to do the physics interpolation with the two skeletons is we have, let me turn all this back on. We have the regular skeleton here, which drives the let me see. Animation. So like it's swaying slightly because it's running the animation. So this is driven by the animation player. But then when the guy gets flung, it stops being driven by the animation player and starts being driven by physics. So what we do is we have this normal, like how you'd expect, where the animation player is driving it, but then we construct the second mannequin that's driven by physics at the start of the game. So it does all the stuff automatically for you. So we go, okay, here's our duplication flags. We want all the signals, all the groups. We don't want scripts, and we want to use a regular instantiation. So then it calls duplicate here with those flags to duplicate our skeleton, and then it saves it as a physics skeleton. So then we have animation skeleton and physics skeleton. And then we give it a name, physics skeleton, because by default it has like a nonsensical name. We want to say nice physical skeleton, and then we remove all the bones because we're not going to need those, and all the attachments and extra things. Then we have a separate script we attach to it, and what does that do? I forget. Um, Here we go. It's just we set the gravity scale to 0 because you don't want it to be affected by gravity, and then we start the physics simulation. And then we basically just use Hooke's law, which is, where is it? Boom, boom, boom. This is something that should be in Godot, but if you look at the actual C++ source code, it's just empty for now. But essentially, we're mimicking that by using this function. Um, what else is there to show you? Oh, and then we make sure to set the owner as the same owner, because if you duplicate something, it doesn't have an owner. And I don't want to get too busy into the details because this is getting kind of complicated. We keep track of the bone names because we have a where is it? Oh, inside the NPC that keeps track of the health of the bones. Yeah, so we have a health for each bone. So, for example, if it gets hit by something, if it gets hit in the head, we want it to die with one hit. So if you shoot the head once, the head's gonna come off. Boop. And if you shoot the arm multiple times, it'll take multiple hits to break the arm off. So here we have the health of it as 100% when the health of everything is set to 100, and then we're using 100 power when it gets hit by something in the head. And then if it's one of the parts of the arm, the hand, the middle, or the forearm or the upper arm, we just count that as one piece and break the whole arm off. So if you shoot them in the hand, it's damaging the whole arm. But I could make it so it breaks the hand off all the way. But for now, it's just gonna break the whole arm off. Oh, there we go. There we go. So it just breaks the arm off at the shoulder. And then, I think that's pretty much it. We're doing the same tuck and shrink technique to where the whole mesh of the person is here. Oh, geez. The whole mesh. So when I break the head off, the whole mesh is actually, for the body, is actually shrank and moved down into the neck here. So that's how we're hiding it. And then for the head, we would just shrink part of the head. Man, the frame rate really tanks on my computer when I'm recording. Let me go to full screen here. There we go. When it's in windowed mode, for some reason it really tears on my 8-year-old computer. But anyway, we shrink it down and tuck it inside the neck here. And then if I break one of the legs off, we shrink the leg and then we tuck it and pull it up into like the abdomen here. So we're doing the same thing that we were before. So that's pretty cool. I don't know what else I should mention. Anyway, the code is at github.com/immersiverpg/example ragdoll. I'll put the new one up here. And we're using the mannequin here. This is from Mixamo. I was having issues with the GD Quest mannequin that wasn't working because it was, unless there was some issue with it, but this one worked a little bit better because like the name of the bones was the naming wasn't working a little bit more consistently, so that switched. But other than that, it's all the same. Anyway, I will let you guys go. Leave some comments on the YouTube if you have any questions or anything. I'm going to put out another video after this one. I know it's been a while since I've done the skeleton stuff, but I'm going to show how to do like um, dragging the bodies and maybe like blood decals and blood spray and a few things like that. But anyway, I will see you guys later.